Thank you so much for the invitation to actually be part of this community. The title of my talk is Good Designers Do X. As I was trying to explore this group, you're new to me, I did what Amy talked about in the panel last night, and I did a word cloud of the titles of the papers from last year's conference. So last year's conference theme was transdisciplinarity and the future of engineering. And you see things like we've heard about in some of the talks today, systems and integrated and learning and performance. But the thing, once you take out the words transdisciplinary and engineering, the thing that really pops is the term design. And that makes complete 100% because design is how we as engineers get our knowledge out into the world. It is how we as engineers, engineering educators, then have to figure out how to teach it. It's also a central component of my very favorite definition of engineering, which is from Bill Wolfe, who was a past president of the National Academy of Engineering in the US. And his definition of engineering is design under constraint. Absolutely elegant in its simplicity. He goes on to elaborate that all those constraints, right? A lot of constraints. We know about constraints. We're constrained by nature, safety, environmental concerns, cost, and a lot of what he calls the illities, maintainability, constructability, reliability. But he also talks about engineering as being creative, about designing what can be, about seeing possibilities. And aside here, whenever I give talks to students and I use this definition of engineering, there are multiple aha moments in the crowd. It's, this is how I can define engineering to my roommate. I've been trying to tell them a long time what it is I do. I do design under constraint. So it might resonate with some of your students as well. So all we have to do then is just teach our students to be excellent designers, right? Case closed. Not case closed, right? Incredibly difficult to teach. Design is hugely challenging to teach. Design, there's so many definitions of design. It's a noun, it's a verb, it's an adjective, it's what we call a final product, it's what we call the sketch of an idea, it's what we call engaging in the act of creation. It's an absolutely essential component of engineering, but it's an important part of architecture, of writing, of composing, of cooking. It's simply an absolutely essential part of being human. We can't claim it. It's important for us, but we can't claim it. Actually, another profession has claimed it. You can get a degree in design, and it's not engineering. Design has entered the commonplace conversation in businesses these days through something called design thinking. Us as engineers, as we're trying to figure out how to teach design, how do we navigate this incredibly complex space? It's tough, but it's something we absolutely have to do because every single engineering curriculum includes design. When we went out to P-Suit's amazing lab at AIT on Monday, he told us about the new MSIE 4.0 curriculum that he and colleagues are developing. And 3 of the 16 courses that they offer are about design. So it's a conversation that we have to be engaging in as engineering educators. So it's a conversation that we're going to engage in for about an hour after lunch, the second day into the conference. So my goals are modest. What you'll be engaging in with me is results of a couple of decades of research I've done on design expertise. There's a wrinkle in the carpet I'm going to try not to trip on. I can't guarantee that. And we will also be engaging in a list from researchers on what good designers do. So you all should have a card, an envelope with cards in it. If you can hold on, we'll be using them about 2/3 of the way through the talk. So if you can't hold on, that's okay. You'll be engaging with something. My goal is that you come away with 1 or 2 things that can connect with your work. And I think that that's a reasonable goal for an after lunch talk. So I'd like to set the stage. I've been working on design expertise and how to teach design for a couple of decades now. And it's because my life professional goal is to figure out how to teach engineering students to think about the impact of technology on the globe, to consider context in their work as they're doing that, and to minimize unintended consequences. Sideline story I could tell you over coffee break. My great uncle was on the design team for the original aerosol spray cans. So you can imagine why I've been interested in unintended consequences for a long time. The frame that I bring to that work is one that I learned about in my EPP, fellow EPPer, Ph.D. in 1990. My thesis work was on risk communication, so taking a mental models approach or understanding what a lay audience already knows about a topic before you develop a communication to work alongside with results of formal risk analyses. My advisor was Baruch Fischoff. His advisors were Kahneman and Tversky, so we were squarely in the behavioral decision theory perspective that is useful to have alongside a decision theoretical perspective. And my first semester there, going back from industry to get a PhD, I was taking research methods, an AI course from back in the 80s, imagine that, and statistics, and then cognitive science from Herb Simon, who was one of the founders of the field of cognitive science. It was a life-changing event for me in two ways. I couldn't believe how much harder I was working in school than actually in industry. I barely survived the first semester. But what I learned from Herb Simon was just life-changing in terms of a perspective of looking at how experts engage in a topic and comparing that with how novices engage in a topic and having that be a foundation for figuring out what to teach somebody. All the things that these have in common is looking at how people actually do something so that we can compare that with how we tell them they should do something. So I was interested in developing descriptive models to couple with prescriptive models when we tell people you should do this thing. So that informed my lifetime of research into design expertise. I was trying to figure out how engineers could consider context. Bill Wolfe tells us engineering is through design. So I want to figure out how to help students think about context through the concept of doing design, with my frame interweaving how people actually do design so we can compare that with how we tell people they should do design. So my questions became, how do engineering students and experts engage in design, and are there differences that can inform how to actually teach design? My audience was us as engineers, and we know that engineers resonate more with quantitative data with large sample sizes than with qualitative data. So I embarked on a quest to gather data from a large number of engineers doing design. This is funded by several grants from the National Science Foundation in the US, with people from various levels of expertise, solving design problems out loud, so they're giving a verbal protocol. I created quantitative measures from that verbal data. And then I was able to do comparisons, statistical comparisons with those quantitative metrics developed from the qualitative data. So I could compare across levels of expertise. I used much larger sample sizes than a traditional expert novice study of the time, which you could read papers with sample sizes of 2 or 3, maybe 6 or 8. And the data I'm going to be describing today is from 69 participants across 3 conditions. So much larger sample sizes than the traditional studies with this research methodology. So I was just setting the stage with what we're talking about. I'll first talk about my design expertise research, and then talk about my more recent research about bringing those results into the classroom with a concept I call design signatures, engaging with this Good Designers Do X envelope you have with you, and then talking about a seminar that I'm giving called Dear Design, and then wrapping up. One odd thing to note, my pandemic experience included a second, not my fault, car accident, which exacerbated some concussion symptoms. So if I occasionally look like I've paused and searching for a word, that's because that's exactly what's happening. And a word generally comes up. It's usually close to useful, sometimes a little bit tangential. So just be patient with me as we go forward. I'm incredibly empathetic with anybody who has any kind of word searching challenges. So I would not recommend getting in a not your fault car accident. Or not either your fault. You know, let's get car accidents off the table here. A couple of times through the talk, I'm going to invite you to engage in what I call a Magritte moment. You may have come across this painting by René Magritte, a French surrealist, called The Blank Signature. I have kept a copy of this on my office door for several decades now. And what it conveys to me is working on a messy problem like how do people design, how to teach design. Everyone in this room is working on a messy problem or you wouldn't be in this room. We can only ever work on one slice at a time. And then the slices that we work on sometimes don't line up, and we have to sort of squint across to actually tell the whole story. And when you're in the middle of actually doing the grueling work on working on the one slice, it's helpful to know that in the end, it'll all come together with some sort of version that is interpretable. So what I'm hoping is that you're thinking about the messy problems that you're working on. And then when I'm talking about my work, maybe one or two concepts will be useful for you that you can connect with your own messy work. Not your work is messy, the problems are messy that you're working on, right? Very, very, very clean work that you're doing. We're all doing very, very clean work. Okay, so here we go, diving into my design expertise research. First thing to note is that we all know that research is a team effort. Across the decade, I've been really privileged to work with an amazing number of people, and all the work that you're going to hear about is the result of team research. Okay, that large corpus of data, I have data from 177 individuals who solved design problems, 401 problems in total, 298 verbal protocols. These 177 people had various levels of expertise, 149 students, mostly incoming first year and graduating senior, 19 practicing engineering experts, 4 educators, and 5 domain experts who had expertise in the domain of the problem that they were solving, which in this case was designing a playground. I'll talk about data from that experiment with people designing a playground for a fictitious neighborhood. The participants that I'll be describing, the results came from 26 first-year engineering students, 24 graduating seniors, and 19 practicing engineering experts. They were asked to design a playground for a fictitious neighborhood, subject to a set of constraints that they were given, cost, timing, number of kids that needed to be kept busy. And they gave a verbal protocol. They solved the problem out loud in a lab as an individual, had up to 3 hours to solve the problem. We analyzed that data by taking the verbal utterances and transcribing it into text, and then taking the text and separating the text into idea units. So every phrase had only one idea in it. 2 people did that independently, argued to consensus for reliability. And then we took each one of these idea units and assigned a design process code to each idea unit. So coding in this case is qualitatively coding a code from a predetermined coding scheme to each idea unit. So that's how we actually coded the data. Oh, next slide. Always need to say. Next slide you could spend the entire hour on, because I'm going to tell you how I defined design. Okay. Everybody has a different definition of design. What I did, since I was coding data from students and wanted to figure out how to teach students, was I looked at the language with which we taught our engineering students about the design process. So I took 7 first-year engineering textbooks where we taught design and did a content analysis, and then looked across the 7 content analyses and found what was common, and it's things that we all completely recognize, right? Identifying a need, defining a problem, gathering information, generating ideas, modeling, feasibility analysis, evaluation, decision, communication, and implementation. In this case, for this problem, identify a need and implementation are grayed out because we gave them a problem statement, they didn't identify the need. We didn't ask them to build the playground. It was a conceptual design. So we were coding with the codes in the middle here. Here's a representation of the experimental setting. I already talked about the participants in a lab-based setting. I talked about how we coded. I'll get to how we represent the data in a minute. This slide is here to just say, not only were we looking at process, that's what I really was interested in, how do people engage in design processes, but we also coded, we assessed the quality of the designs that they created, because we wanted to map their process to the quality of the product they created. How did we represent the data? You can represent how an individual traversed the design activity codes that I talked about through a timeline where we have the design activity codes in the same order I talked about here in the y-axis, and time goes from left to right with a slash on an activity if a participant spent time in that activity. So let me give you an example. So somebody said there was an experiment administrator. They could ask for information from the administrator. Do you have a list of materials? That was coded as gather information. And so a slash was put on the gather information line. So this person read the problem statement, gathered some information, generated some ideas, and then a lot of time spent on modeling. These are the representations that we use. And the next slide is a very busy one that I'm going to ask you to engage in. This has sample timelines from 3 first-year students and 3 graduating students, with the top row having students who created low-quality playgrounds, the middle row, students who created middle-quality playgrounds, and the bottom row, students who created high-quality playgrounds. And I'm wondering, if you look at these timelines, what you see, do you see differences between the first year and the graduating seniors, and do those differences involve the quality score? What observations do you have? Yeah. Uh-huh. Yep. Yep, absolutely. What other observations? Linda? A lot more modeling, particularly with this student. Yeah. Yeah. Pardon me? First years don't have the, right. First years don't have the skill set, yeah. Any other observations? Yeah. Oh, you've got the
I've got a mic, yeah, so I can make really loud,
here, you
really loud observations. Less modelling as you go higher quality. It seems to be more what I guess is more cyclical.
Yes, yeah. There's a lot more iterations as you get to higher quality. Absolutely spot on observations. If you look at the incoming first year data across all 26 of the students, most of the students actually look like some variant of this. This one's pretty extreme, where they read the problem statement, gathered a little bit of information, generated a couple of ideas, grabbed onto one idea, and then just modeled the hell out of it. Face down on the table. A quarter of the students actually looked like the top low-level quality playground design. And those students read the problem statement, came up with an idea, read the problem statement, gathered a piece of information, read the problem statement, gave up. Actually weren't able to grab onto something to make into a final product. So we had a quarter that looked like this, most of the students who looked like this, and a couple incoming first-year students having a rich set of transitions and iterations across the process. With the graduating seniors, all of the graduating seniors doing a lot more information gathering and generating and understanding the problem up front, and also a lot more transitions. Yeah. Pardon?
If I look at, so it's just I'm really nosy now. If I look at that from the graduating seniors, the patterns are still quite similar. So the quality is done. There is a change on the low quality one to a bit more modelling.
Can you say what looks similar?
So I look, it's kind of spread out and they've got a bit more mix. As you say, there might be more in the bottom one on the graduating senior, so there's more of that, it's more numbers.
Yeah.
Okay.
Yeah. And if you actually do then the statistical comparisons with these quantitative metrics that I developed, graduating seniors were significantly more likely than first years to have higher quality designs. This was a huge relief to me. I could have published the results anyway, but I was like, okay, the 4 years did something. They also made more transitions among design activities. They scoped the problem more effectively by considering more categories of information, and they progressed further into the design process, that observation that people got to the communication as they were graduating seniors. If we add the expert data in, from the 19 experts, you can see, and we actually do, well, I'll just tell you here, the engineering experts were significantly more likely than students to spend more time solving the problems in all the design stages. So the experts sort of stayed at the table longer. They were willing to engage in the problem longer. They scoped the problem more effectively by gathering more information, covering more categories. They spent longer problem scoping before turning to modeling. So you can see that there's much more time spent understanding the problem before choosing an idea to actually do some modeling. They considered more objects in their design process, so they basically came up with more alternatives. And they exhibit what I call a cascade pattern of transitions, moving from the upper left in this order of activities down to the bottom right. Found similar patterns with individuals solving other design problems, with participants from other populations, from students from a different university, from engineering faculty, from domain experts. You see the similar cascade pattern. With other experimental designs, so I've talked about an across-subject design here. I have data from within subject longitudinal comparison. So I took gathered data from incoming first-year students, still had money when they graduated. So I asked them to solve problems again. So I had much more power with those kinds of analyses and saw very similar results. And also, I know there's questions in the audience. These data are from individuals. We did analyze some data from a team, and we see similar patterns as well. So robust findings with these similar kinds of patterns across lots of different experiments. Took several decades to actually collect and analyze these data. Want to say something else other people are remembering in the audience. Remember that these data do not include identify a need or implementation. So if you were to collect data from the real world problem solving instead of a lab-based setting, you would see a continuation that would include transition with these design activities as well. Okay, so the timelines themselves end up resonating with a lot of people and are really sort of a canvas for the research results. So using the timelines to actually convey the top level results that I try to teach students is moving towards more experienced design behaviors. You see thorough problem scoping at the start of the process before turning into modeling. You see robust information gathering, and it is throughout the process. It's not just understanding the problem up front, but it's all the way through the process. You see a lot of agile, fluid transitions and iterations throughout, going back and gathering that information. And then you see you actually do have to choose something and stick with it at some point. So the timelines end up being really great ways to convey to people the general findings across the research. And that's where to connect context in. That's where we can tell our engineering students, you understand the problem, that you need to understand the full context. This is where in transdisciplinary engineering, we say you have to understand the problem at the beginning and you have to gather information throughout the whole process. You have to iterate and go back and make sure that you're not only gathering information, but as our keynote speaker, the second keynote speaker said, that you have to be checking your assumptions all the way through the design process. So iterating and going back is an important component. It's not a waste of time. It's being effective. One student, when I presented these results in a class, sketched on top of the high quality graduating senior timeline what they called an ideal project envelope. And that's that cascade shape of understanding the problem at the beginning, doing the modeling, choosing something, gathering information, and then coming to completion. So many people told me that my timelines look like music, that we sonified them. So here we can listen to, this is listening to the incoming first year student with the middle quality design. The sound of average design. To contrast, this is the sound of more expert design. A rich cacophony. So, to summarize, more experience, more complex processes, more fluid, more dynamic moving across design activities, being cognizant that you need to understand the problem the entire way through. So this is the first Magritte moment. Any of these research results connect with you and the wicked problems you're working on. All right, so next, after working on what do design experts do, I'm moving on to now what? So revisiting my questions, do engineering experts and students, do they have different ways that they engage in design? Yes. Are there differences that can inform how to teach design? I would say yes. And can they help us teach engineering students to consider context? I would also say yes, but now the question is, how can they be useful in teaching design? We teach design so many different places in the engineering curriculum. Capstone design, first year design, makerspaces, design spine, classes, service learning, so many different places. Where might these results be useful? Well, how do we usually teach design? We usually teach design with prescriptive models, node and arrow. This is a prescriptive node and arrow model of the one that we used in our experimental data. The mechanical engineers in the audience will recognize Paul and Beats. There are literally a billion different ways that you can represent design process models. That's what Google says anyway. And recalling George Box's very prescient quote, all models are wrong, some are useful. All the models that we use to teach our students are simplified, they have to be. And I would posit that adding the timeline alongside whatever prescriptive models you use to teach design can really be useful. It's like we tell our students, okay, do this process, but not in order. You should do it like out of order, and you should remember to iterate, and that means follow an arrow on this prescriptive model here. And if you actually couple the timelines with that, you can say, here's an instance of design. This is what I mean by follow it, but don't follow it in order. And this is what I mean by going back and iterating. So, are they useful when you teach students with these representations? Well, that answer ends up being yes. Have given this talk with lots of students. Here's a mechanical engineer's student's response. Super valuable, much more compelling to see real data, detail, makes me believe instead of tuning out prescribed information because you can't trust how they derived it because you don't know. As engineers, we really want to know how the data were derived, right? And these data show, at least for these instances. Here's a response from a civil engineering student. Cool, so cool to see, as statistically relevant because now I can prove to people that understanding the problem first is crucial for success. Yay. And this student actually got what Professor Yamamoto, AIT's president, said yesterday in his opening remarks. A problem well stated is a problem half solved. So this student got that message. When I present these data with students, they make amazing observations. I need to be broad, I need to iterate, I need to gather information, great kinds of observations, which was really exciting for me. But then my question over time became, well, will it really affect their practice? Okay, I've heard in several sessions at the conference, it's not, you don't only have to know something, you have to be able to use it. You have to be able to put it in practice. So my next challenge became, how do you make this active? How can you make these results live? How can you help a student live and see their own design processes? And so that's what I'm going to be turning to next. We have about 2 hours for this talk, right, PC? All of my practices went in 49 minutes, and so I have 49 minutes left, right? Okay, we'll see. I have a couple of off-ramps, so we'll see how we go. So I'm going to be talking about design signatures. You'll be engaging with the Good Designers Do X mini card deck that you have, and then maybe I'll tell you about the Dear Design seminar. Design signatures is this concept I've been developing after a conversation with Ade Mabugunje at Stanford. If you think about the last time you engaged in a design project. You can think as you were traversing all of these different design activities, you were sort of leaving behind you an invisible tracing of how you engaged in these design activities. And what we're doing is we're calling these invisible traces, we're calling them design signatures. Like what was the design signature that you engaged with the last time you engaged in a design process? There's a couple of affordances to the concept of signatures, and one of them is that signatures can vary according to function. So these are two of my signatures, same person, so like same design process, but one of them is for a reference letter for a student, and one of them is buying a cup of coffee. Okay, that's the same name, believe it or not. And it's a useful topic or concept to use when you're thinking about design projects. So if you are trying to work with a set of students in a senior capstone design, you would want them to have a rich navigation like that graduating senior, understanding the problem richly and doing a lot of iterations. But if you were engaging in a 3-hour hackathon on a Saturday afternoon, maybe not enough time to actually do this. Maybe this is actually a better kind of design signature to have. So you can think about the concept of a design signature as how you have progressed through a design process, and you can use it as a planning tool to say, how might you choose to engage in a design process going forward? So student at a hackathon, what design signature do you want at the end? You can use it to monitor your process, compare it to experts, reflect when you're done. You can also think about a signature. So the gymnast Simone Biles has a signature balance beam move. You know it's hers. And so you might actually have a way that you want to engage in design as your aspirational design signature. So you want to be the idea generator. You want to be the closer. You want to be the X kind of person, so the X kind of designer. So you could have an aspirational design signature. So my next steps became, how do you create opportunities for students to live their design signatures? How do you make it not just looking at this timeline on a screen, but how do you help students embody the process of design? How do you actually help them make the invisible visible? So I've done that a couple of ways. Started with just building on work that Chong and Foster did, just using paper and pencil, having students fill in bubble sheets on how they navigate a design process. These are actually in a 10-minute design challenge in a teamwork class, one student of a team being a user researcher and the others actually engaging in a team project. And so you can look at the timelines, how time was spent, and you can compare them. Then the pandemic happened, and so we had to do the same thing with Google surveys in Zoom breakout rooms, so you could do the same thing. So we've been providing ways for students to actually trace their own processes. And as we were doing this with bubble sheets, I was working with an amazing set of undergrad students. We were investigating a concept we call design awareness, which I don't have time to go into right now, but could in the question answers. But we went, okay, what would it be like if we actually could use our phone and trace our processes with an app? So we built an app where you can synchronously, you can track your design processes synchronously or asynchronously. We seeded with some models that are in there already. So the models that I have in my research, we have a converge-diverge model, but here's the most important thing. You can create your own design model. So you could use these with your students with the design model that you teach. And students could then, or anybody, track their own design process, and the app creates timelines for you. I've been working with colleagues since January across the country, and we call ourselves the Design Signatures in the Wild group, and we've been collecting various versions of design signatures with Google Forms and with the app, and I'll show you, here is our results from the app with synchronous tracking, a 12-minute design challenge in a class with one person as the user researcher, and you can see how people allocated their time across design processes, and you can have really great conversations comparing the results of the work with the processes that people engaged in. This is my colleague Reed Bailey at University of Virginia used the asynchronous mode. So in the design capstone process, like you can't turn on an app and then collect data for an entire semester synchronously. So in the asynchronous mode, you can once a week have a team get together and say, how did we allocate time, input that data, and then create a timeline across the whole semester. And you can create these boundary objects that allow you to actually have a conversation about how your capstone design team is doing compared to how they would like to be doing. These boundary objects end up being really useful. Students have lived a design process, they can see it, and then they can reflect on it, and then they can make changes for the next time. They really resonate with them, making connections across descriptive and prescriptive models. These are Likert scales. Purple's good. They said it was useful and it was worth spending their time on. Second quick Magritte moment. Anything from the design signatures? Not inviting questions. This is connections for you. Questions at the end. Is it a I'm sorry, that was too abrupt. Is it a clarification question? I wanted you to get to your packets. Okay.
You mentioned that you were working with civil engineers and mechanical engineers, and the design results in a physical thing somehow. But I was thinking about industrial engineers they work with operation research and mathematical programming, or computer engineers who work with software. And I would guess that they follow the same process.
Absolutely. Absolutely. Yeah. Yeah. Thank you for asking that. Okay. So next challenge was, I love my process research. I was then going, okay, this wasn't enough. I really wanted to have students really dive in and live with themselves as designers, and was creating the Dear Design seminar, which maybe I'll get to, but maybe not. But as I was creating that seminar, I was going to focus on my research, because my research is really awesome. However, I recognize that my research is just a teeny tiny slice. It's one of those slices, right? Design is so much bigger than that. The landscape of design includes so many of the things that we've talked about in the conference so far. It includes listening, right? We've heard that from so many people in so many different sessions. It includes valuing diverse voices. So compelling, keynote speaker number 1. It includes understanding assumptions, keynote speaker number 2. It includes all the things the panel was talking about last night in transdisciplinary design. Are we buzzing? Can you turn yours off? Okay. Stopped magically. Thank you. Collaboration, reflexive critical thinking, systems thinking. It includes responsibility. It includes thinking about values. It includes community. It's a mindset. Like, how could I choose from this entire landscape what else to include in this seminar? And we were in a pandemic, and so I was thinking, why don't we actually crowdsource that question? So I asked colleagues in the engineering design education and the design research community by email. I sent an email saying, if you talk to somebody and say, good designers do X, what are the top 4 or 5 things that you list? Looking for just off the top of your head answers. And I got immediate responses. And I have this beautiful set of responses from 28 scholars with 140 statements. These are the contributors to the list. And they say things like, Reed Bailey saying, good designers are constantly learning about problems and solutions and skills. Nigel Cross is saying, good designers take broad systems approach to a given problem rather than accepting narrow problem criteria. David Henry saying, good designers consider planetary limitations. Janet McDonald saying, good designers attend to the ethics of their professional actions. Laura Murphy saying, good designers understand that every design decision impacts a person's life, even if they can't witness the impact themselves. Sherry Shepard saying, good designers do not fall in love with their own ideas. Students love that one. And Jennifer Turn saying, good designers include as many people in the process as possible. They make design social. And so what I'm going to do is ask PC, what time did we start? What's the ending time? Okay. So what we're going to do, pardon? Yeah, okay. I'd like to invite you to engage with a subset of the Good Designers Do X list. So you have an envelope. The stack actually is this tall. Each person has a randomly selected set of 5. And I'd like you to flip through it and choose one of the statements that resonates with you, and then share it with your neighbor, and discuss how these cards might be linked to transdisciplinary engineering. And you have 1.5 minutes. You have 2 minutes to do that. Okay. Does anybody want to volunteer a quote and then a link to transdisciplinary engineering? All right, let's look. Go ahead, read the quote and who it's from, and then your link.
From Micah Land, our good designers are comfortable in ambiguity while reducing uncertainty. It relates to me deeply personally, but also I think transdisciplinary interdisciplinary research and your wonderful diagram art of the horse. I mean, nothing, it's all, even though we strive to have the complete picture, you can never have it, and you just have to be comfortable with that.
Right, absolutely. Another volunteer, a quote and a link.
Hello. Yes, and by coincidence, my colleague and I picked a quote from the same person.
From Micah. He will be so excited.
Peter Lloyd.
Oh, Peter Lloyd. Oh,
Yeah,
okay.
yeah,
The two of you from Peter. Yes. Okay.
Yeah.
And which?
So I chose know when to lead, facilitate, listen, collaborate, and act. And the other quote was balance analysis with creativity.
Yeah.
Yeah.
Peter has amazing insights, and that they link to transdisciplinary engineering. How?
Yes, I think good advice for anybody to take to heart. Yeah. Mm-hmm.
Agreed. Absolutely agreed. This card deck really resonates with students. I have students do lots of different things with them. They do affinity grouping, mapping to other models, choosing a quote and then using it as a thread for them to listen to other people's presentations and do a reflection afterwards. So many different rich things you can do with the quotes. I chose a couple of postcard representations that comes borrowing from the next section that I thought this community would resonate with. So these are postcard representations of individual students' design processes, and these are ones that were inspired by this list. And here's a student, here's the key on the back of the postcard, design activities, and then figures in either black or gray representing stakeholders, with the black ones representing stakeholders who are involved in the process, and gray ones indicating stakeholders who should have been involved in the process. Huge insight for this student. I left people out. Another student, many of whom were in human-centered design and engineering, creating her UX toolkit, says that the multidisciplinary considerations and mindsets, knowing that disciplinary thinking and first principles in design are not simply about natural sciences and economics, but also include ethics and social sciences. I chose that one for you, Adam. So, students ask me, can I buy a deck? Students see themselves as part of it. They see themselves as part of a community that they want to be in when they see these statements. And then I have students reflect basically after each class, and all of the reflections say something like this. Design is this big. Design is something I am. Okay, really quickly, I'll talk about the Dear Design seminar that inspired me to pull together that list. Oh, by the way, that list should be on my website, on our website by the end of the summer. It'll include a spreadsheet that you can download and use in interactive Miro board kinds of things. And you can print your own cards, currently in an 8.5 by 11 format. If there's anybody here who knows Figma and has extra capacity and might want to put them into an A4 format for more global accessibility, please let me know, because I would love to do that. Okay, love my process research, trying to teach students to own their process, to be aware of their process, to sink deeply into their process. And what I did was encountered this beautiful book by Lupian Posevich called Dear Data. If you haven't seen it, I really recommend it. And it inspired me to use postcards as a form function to have students record their processes. So I created a 10-week seminar where students each week do a design process, represent their process on a postcard, and every week they interpret their design process through a new lens. And at the end of the 9 weeks, they are deeply reflective, have lived their process, and have increased their confidence as a designer. And I'll tell you a little bit about the process, and all of the materials are on my website. So across the 9 weeks, there's some nuts and bolts kind of things like how do you capture design, how do you represent design. Here's where they're diving deeply into design process models. How do you code design, looking at the many models, engaging in my research results. But here's where they're engaging with sort of this larger landscape of design, thinking about what counts as design. What kinds of questions can I ask myself if I'm trying to be aware of my design process? And we can talk more about that, sort of building on Schoen's concept of reflection in and on action. And then engaging at the end with this good designers do X list, where their brains just then go. And the final assignment is I ask students to create their aspirational design signature, or who they want to be as a designer going forward in their lives. This is a sample of aspirational design signatures that people came up with. And you can access all of, we ran 2, Grace Barrar and Juliana Flores worked with me, and we ran 2 sections of an online seminar. This is the website we developed, where you can see a brief description of my design expertise research. You can get access to the app if you want to trace that. We use that in the seminar. And then if you go to the Dear Design link, you can see 200 postcard representations of students saying, this is my design process. So keynote speaker 1 saying, we need to connect art and science. Design and engineering is how we can do that. All the teaching materials are on the website, and please feel free to steal, adapt, use whatever you like. Okay, so yes, so finally, I asked students who were engaged in the design seminar 2 months after the seminar, did it affect how you do design? And they're saying, yes, I find myself planning, explicitly planning. I find myself paying way more attention to the process when I'm in it. And I feel very strongly like a designer with purpose and intent. I feel much more secure and confident when I do design. A mini Magritte moment, so we can get to the workshops. And quickly wrapping up. All right, so after lunch, a day and a half into the conference, modest goal, after engaging with some design expertise research and this beautiful list from scholars across the globe on what good designers do. I'm hoping that perhaps you came away with 1 or 2 things that connect to the messy problems that you're working on, and invite you to, I'm happy to post the slides, share all of this work. The website has research. You can get the app. You can see all of these beautiful postcards of beautiful design representations. And Good Designers Do X, I am hoping, is coming at the end of the summer. I'll end with 1 more postcard that I think this audience would really resonate with. And that is, here's a student design activities that she chose. And here's her talking about herself as self-awareness and reflective designer who's incorporating ethics and considering an inter and multidisciplinary considerations and mindset. So I hope that design might be a way that we can teach our students about the absolutely essential parts of transdisciplinary engineering. And I would love to take questions in the -2 minutes that we have.
Fabulous presentation, thank you. Absolutely, just, completely blown away by it. Brilliant, thank you. So let's take a few questions from the floor. I've got loads of questions otherwise. So whilst you're thinking, there was one thing that struck me, just that's a kind of soft opener in a way.
Okay.
So in the what you've been trying to do your whole life, the third one was avoid unintended consequences, which I guess is a kind of, it's a bit like the medical model, do no harm.
Right.
But is there not an opportunity for design to take advantage of creating benefit, unintended benefit in a sense, but intentionally? So is that also part of it?
Absolutely. Yes, I would say that yes is the answer. And I think that your work is actually, really heading in that direction and could really inform that.
Great. So, Ira.
Thank you so much. For the playground exercise, what was your method for evaluating the quality of the playgrounds?
Yes, really good question. So what we did was there were 3 components to the quality score. One was, did they meet the set of constraints that they were given? So they were given 7 constraints, so did they meet the constraints? Second was, we actually compared it to actual playground standards. So we looked at playground standards and said, okay, did you measure up? And the third part was a Likert scale rating of qualitative aspects of the playground, like would the kids have fun? Did you consider the parents? Like, is there a place for the parents to sit down and those kinds of things? And they were all equally weighted.
Everything to like 7 or 8 different categories.
Correct.
Are those the right categories? If you could do it over again, is that what you'd use?
That's a really interesting question. What we would find is it was difficult to differentiate between feasibility and evaluation. So feasibility of a solution and evaluation across alternatives. The decision code that we used, we actually found that the decisions people were making were micro. Should I include should it be a nut or a screw, instead of larger level decisions? And that's because people generally were not creating many different full alternatives. They were just making micro decisions along the way. So I would need to engage in a lot longer to go, what would be a new one? If you saw in my app, I included whoppingly different model like diverge converge, and I've had students actually just do a 2-level coding, and Cross and Dorst's work on problem framing and solution setting. Just having a binary code is quite useful and can give all kinds of insights. So oh boy, like I don't want to redo all of those things, but that question really spurs a lot of interesting ideas.